Hi, my name is Young Han Khoi, and today I will present the exercise 6 of the subject identification and system control. The exercise is to design a feedback linearization control for nonlinear system or nonlinear control. In this presentation, I will consider a pendulum system which will have the equation ml squared times q double dot plus b times q dot plus m times g times l times sine q equal u, where the weight of the pendulum is 0.1 kilogram, the length is 1 meter, and the damping coefficient b equal to 0.01. To Now the quest is to design a feedback linearization control for the pendulum, which will have the overshoot smaller than 10% and the settling time is smaller than 0.3 second, and the reference is a pole signal. Now, to design for the system, we will do step by step. First of all, we define state variables for of the pendulum system. x1 equal q, which is the angle. s2 times s2 equal to q dot, which is the angular velocity, and the output is y equal q equal s1. Now come to the step 1 is to compute the time derivatives of the output checking error. The checking error equation will look like E equal to yd minus y, where yd is the reference output and y is the output of the system. Now we derivative the tracking error, and we will have the equation number 3, E dot equal yd dot minus y dot, and we derivative one more time, and we will have the equation number 4 is E double dot equal to yd double dot minus s2 dot. We can rewrite the equation like yd double dot minus fx minus gx du, where fx is equal to minus g over l sine x1 minus b over ml squared s2, and gx equal to 1 over ml squared. Now come to step 2, design linearization control. We have the equation number 5 is u equal to g s power minus 1 times the minus fx plus b. And by replacing number 5 into number 4, the result is presented as E double dot equal to yd double dot minus b. Now come to step 3, we design a tracking control. We have the equation number 7 over here. And come to step 4, select the control parameters. By substituting equation number 7 into equation number 6, we will have the equation number 8, which is E double dot equal minus K1 E dot minus K2 E. And the characteristic equation, or the equation number 9, will look like S squared plus K1S plus K2 is equal to 0. Now to design the feedback linearization, we need to base on the design requirements. So the first requirement is the overshoot must be smaller than 0.1 or 10%. The formula for overshoot or POT, we can get it from the theory of automatic control system. So based on the formula, we get the damping coefficient is equal to 0.7. And the other requirements of this system is settling time. It must be smaller than 0.3 seconds. The formula for the settling time is also by we can find in the theory of automatic control system, and from that we can find the Wn equal 25. Now the desired characteristic formulation is s squared plus 2 dynamic coefficient times the Wns plus the Wn squared equals 0, and it will equal to s squared plus 35s plus 625 equals 0. And by comparing the equation 8 and the equation 9, we can find the control parameters like k1 equal 35 and k2 equal to 625. Now come to the step 5. Design the low pass filter. We choose the low pass filter GLFS equal to 1 over 0.1 s plus 1 squared, which is the equation number 10. So that's all. So that's all for the theory for design. Now we come to the simulation. To simulate the system, I will do it in the MATLAB or Simulink. Now, first of all, I will set up some. I will set up for the Simulink. The first one is the fixed step size. It must be. It will be equal to 0.01 second, and the simulation time is 30 seconds. Now the complete system will look like this. Now I will start simulate the system. And before go to simulate on the MATLAB, I will introduce a little bit. In this system, it consists of 4 blocks. First one is the reference, tracking control, linearization control, and the pendulum block. So first I will create a file. So this is the complete system of the pendulum. I will create a new file and simulate on it. First of all is the reference block. The reference block is the subsystem in MATLAB. Now it's just for subsystem. In the subsystem, inside the reference block, we have the pulse generator, low pass filter, 2 derivative to get the YD derivative and YD derivative 2 times. So first of all, pulse generator. Transfer function derivative. For the pulse generator, we will change some parameters, just like in this slide. First of all is the amplitude and period and pulse width. Okay, pi 3 20 50. Okay, I forgot to set up. We set up the fixed time step, the fixed step for the simulating 0101. Okay, and stop time is 30 seconds. We save this file to this PC. And um, the second block is the tracking control block over here. So this one is the MATLAB function. MATLAB function. The equation for this MATLAB function I have already copied and pasted in this slide. So all I have to do is to paste to this one. Okay. This one is tracking control. The second block is the next block is the linearization control. So the same as the previous one. This is also a MATLAB function. So I copy the code over here and paste it. Save. This is the linearization control. The third block is the pendulum block. The pendulum is actually a subsystem just like the reference block. So I will create a subsystem. So inside the pendulum block, in this subsystem, it will look like this. It will have one input port, two output ports, two integrators, and one MATLAB function. Okay, two MATLAB function. Integrator. Two. Paste. Copy. Save. Pendulum. J Q Q and QD. Q Q D U. Okay, Q here. Okay, this is the pendulum. So the final step is adding some scopes to see the result and the add block over here. So this will take some time. I will skip this part. Came back. Hmm. So I have already finished simulate the system, the pendulum system. The uh, the result will look like this. Here is the control input. Here is the output response, and here is the error. Okay, so that's all for my presentation. Thanks for listening.